In this video, we will take up with some selected numerical problems based on electrical charges. These numericals are important for your board examination as well as for your competitive entrance examination. So without wasting our time, let's move forward with these numericals. Numerical number 1. The surface charge density on a circular region is given by 3r plus 4 microcoulomb per centimeter square. How much charge will be present in a ring formed between radius r1 equal to 2 centimeters and r2 equal to 3 centimeters? We can imagine a charge distribution according to this formula 3r plus 4 microcoulomb per centimeter square. In this charge distribution, we can also imagine a ring whose inner and outer radius are 2 and 3 centimeters. The inner radius is 2 centimeters and outer radius is 3 centimeters. Whatever is the charge which is enclosed in this ring, we want to find out this charge. In order to find out this charge, we can take up with the charge distribution. We know that dq upon dA is equal to sigma. By cross multiplication, dq will become sigma into dA. This equation is giving us the relation between dq charge and dA area. But we want to find out the relation between charge and radius. Since the areas, whatever we are doing, they are circular areas. So area of a circle is given by pi r square. If you differentiate this equation with respect to radius, we'll be getting d upon dr of area, d upon dr of pi r square. It will be dA upon dr. Pi we can take it outside. Differentiation of r square is 2r. We will be getting dA upon dr as 2 pi r, or dA will become equal to 2 pi r dr. This equation is giving us the relation between the area dA and radius dr. We can put the value for dA from equation 2 in equation 1. If you put the value here, this equation 1 will become dq will become sigma into dA. What is dA? dA is 2 pi r dr. Sigma, according to this numerical, is equal to 3r plus 4 microcoulomb per centimeter square. So we can put the value for sigma, which is 3r plus 4 into 2 pi r dr. This is the required equation which we are supposed to integrate to get the required result. We can find out the total charge Q by integrating 3r plus 4 into 2 pi r dr from 2 to 3. In this equation, 2 pi is a constant term. We can take it outside. Integration of 3r plus 4 into r dr from 2 to 3. We can multiply r inside. We will be getting 2 pi integration of 3r square plus 4r dr from 2 to 3. Now we can integrate each term one by one. We can open the bracket also. It will be 2 pi integration of 3r square dr plus 2 pi integration of 4r dr from 2 to 3 from 2 to 3. From here 3 can be taken outside, it will be 6 pi. Integration of r square dr is r cube upon 3 from 2 to 3. Plus 4 can be taken outside, 8 pi. Integration of r dr is r square upon 2 from 2 to 3. 3 and 6 will cancel and 2 and 8 will cancel. We will be getting 2 pi r cube from 2 to 3 plus 4 pi r square from 2 to 3. This is the total charge which is present in the ring. We can substitute the values to get the required result. And the result was Q is equal to 2 pi r cube from 2 to 3 plus 4 pi r square from 2 to 3. It will be 2 pi 3 cube minus 2 cube plus 4 pi 3 square minus 2 square. 2 pi 3 cube is 27, 2 cube is 8 plus 4 pi 3 square is 9 minus 2 square is 4. 2 pi 27 minus 8 is 19 plus 4 pi 9 minus 4 is 5. It will be 19 into 2 is 38 pi plus 5 into 4 is 20 pi. Now it will be 58 pi microcoulomb will be the total charge which is present in the ring which is formed in the radius 2 centimeters to 3 centimeters. And here also the answer is 58 pi microcoulomb, which is a charge enclosed by this ring. Second numerical. A spherical shell in which charge is distributed such that the charge present per unit volume is given as 3r plus 6 microcoulomb per centimeter cube. What will be the charge present in a spherical shell having inner and outer radius as 3 centimeters and 4 centimeters respectively? Now let us imagine a spherical region on which charge is distributed according to this expression 3r plus 6 microcoulomb per centimeter cube, and we can imagine a spherical shell whose inner and outer radius are 3 centimeters and 4 centimeters respectively. We want to find out the charge in this region, which is in between 3 and 4 centimeters. And what are we given to us? We are given to us rho, that is charge per unit volume, which is 3r plus 6 microcoulomb per centimeter cube. Since we are given rho, that is charge per unit volume, and dq upon dv, so dq by cross multiplication will be rho into dv. This equation is the required equation in between charge and volume. We can find out the charge in a given volume, but we are given radius in terms of radius. For any spherical region, the volume of a sphere is given as 4 upon 3 pi r cube. We can differentiate both sides with respect to radius. d upon dr of v, that will be d upon dr of 4 upon 3 pi r cube. It will be dv upon dr 4 upon 3 pi, we can take it outside, and differentiation of r cube, it is 3r square. 3 and 3 will cancel from here. we'll be getting dv upon dr as 4 pi r square, or dv will become equal to 4 pi r square into dr. This is the required expression of dv in terms of dr. We can put this value dv here in equation 1. What we'll be getting? We'll be getting dq as rho into dv. dv is equal to 4 pi r square dr, and rho, which is given to us, it is 3r plus 6 into 4 pi r square dr. This is the required equation or required expression for charge, which we are supposed to integrate to calculate the total charge within inner and outer radius as 3 and 4 centimeters respectively. We can calculate the total charge Q by integrating it 3r plus 6 into 4 pi r square dr from 3 to 4. In this expression, 4 pi is a constant term. We can take out 4 pi outside. We'll be getting 3r plus 6 into r square dr from 3 to 4. We can multiply r square inside. We'll be getting 3r cube plus 6r square dr from 3 to 4. Now we can integrate each term one by one. Integration of 3r cube dr plus integration of 6r square dr from 3 to 4. Here we can take out 3 constant terms. Integration of r cube dr is r to the power of 4 upon 4 from 3 to 4. Similarly 6 and integration of r square dr is r cube upon 3 from 3 to 4. We'll be getting 4 pi 3 upon 4 into r to the power of 4 from 3 to 4 plus 6 upon 3 r cube from 3 to 4. 6 upon 3 will cancel, it will be 2. Now if you substitute the values, how much you will be getting? The total charge Q will become equal to 4 pi, it will be 3 upon 4, it is r to the power of 4 from 3 to 4, that is 4 to the power of 4 minus 3 to the power of 4 plus 2, then it is r cube, it is 3 cube, 4 cube minus 3 cube. It will be getting 4 pi as 3 upon 4, 4 to the power of 4, 16 square 256 minus 81 plus 2 times 4 cube is 64 minus 3 cube is 27. 4 pi 3 upon 4, 256 minus 81, it will be 5, it will be 7, 175 plus 2 times 27, 37. And when you solve it out, when you open the bracket, it will be 4 pi into 3 upon 4 into 175 plus 4 pi into 2 into 37. 4 will cancel. 175 into 3 is 525 plus and 3 into 37 to 525 pi plus 296 pi. The charge which we will be getting is 821 pi microcoulomb. Third numerical. 4 conducting spheres 1, 2, 3 and 4 having radius as 1 cm, 2 cm, 3 cm and 4 cm respectively. A total charge of 120 microcoulomb is to be distributed among these spheres in such a way that the surface charge density of charges on them is same. What is the magnitude of charge on each sphere? Now, according to this numerical, let the 4 spheres be 1, 2, 3 and 4. They have got different radius. The radius of sphere 1 is 1 cm. The radius of sphere 2 is 2 cm. Radius of sphere is 3 cm and radius of sphere 4 is 4 cm. All the 4 spheres has got different radius. The charges are to be distributed in such a way that the surface charge density is same on all the spheres. That means sigma is same in all the cases. Sigma is a constant term. Let the charge on sphere 1 be Q1 and the charge on sphere 2 be Q2, charge on sphere 3 be Q3 and charge on sphere 4 be Q4 in such a way that the total charge which is to be given to all the spheres is 120 microcoulomb. That means Q1 plus Q2 plus Q3 plus Q4 is equal to total charge Q, and the total charge Q is 120 microcoulomb. Now we can find out the individual charges. First of all, we know that the charges, when they are to be distributed in such a way that the surface charge density is same on all the spheres. That means surface charge density, charge per unit area, is sigma and it is constant. Or by cross multiplication, Q will be sigma into area. Area of a sphere is equal to 4 pi r square. The charge is equal to sigma into area is 4 pi r square. Sigma and 4 pi are constant terms. We can say charge will be depending upon the square of the radius. If sigma has to be same on all the spheres, then the charges should be distributed on each sphere in the ratio of the square of the radius. It means that the ratio of the charges Q1 is to Q2 is to Q3 is to Q4 should be in the ratio of R1 square is to R2 square is to R3 square is to R4 square. R1 is 1 centimeter, R2 is 2 centimeter, R3 is 3 centimeter, R4 is 4 centimeter. It should be 1 is to 4 is to 9. Now if this should be the ratio, let the spheres have got charges as Q1 is equal to, we can talk about x, and Q2 is equal to 4x and Q3 is equal to 9x and Q4 is equal to 16x. We can assume that x can be any charges on each sphere we can find out in this way. Now we are given that the total charge sum of the all charges Q1 plus Q2 plus Q3 plus Q4 is equal to 120 microcoulomb. Q1, Q2 is equal to 4x, Q3 is equal to 9x, Q4 is equal to 16x is equal to 120 megajoule. 30x. 30x will be 120 megajoule. X will become 120 megajoule upon 30. X will become equal to 4 megajoule. Now when we know that X is equal to 4 microcoulomb, we can find out the individual charge. The charge Q1 is equal to X is equal to 4 microcoulomb. Q2 is equal to 4x, it will be 16 microcoulomb. Q3 is equal to 9x, it will be 36 microcoulomb. And Q4 is equal to 16x, x 16 4 the 64 microcoulomb. If X is known to us, X is equal to 4 microcoulomb, so we can keep on putting the value for X. Q1 is equal to X is 4 microcoulomb. Q2 is 4x, 4 into 4, it will be 16. Q3 is 9x, 9 into 4, 36 microcoulomb. Q4 is 16x, 16 into 4 is 64 microcoulomb. That's numerical number 4. Two conducting spheres A and B having radiuses as 3 centimeters and 4 centimeters respectively. A charge of 147 microcoulomb is to be distributed among these two spheres in such a way that their surface charge densities are in the ratio of 2:5. What is the magnitude of charge on each sphere? Now, according to this numerical, let the two spheres be sphere A and sphere B. The surface charge densities on the two spheres are in the ratio of 2:5. That means surface charge density on sphere A and the surface charge density on sphere B is in the ratio of 2:5. Surface charge density of A, we can call it as 2x, and surface charge density on B, we can call it as 5x. Now x can be any constant term x. We can say that the surface charge density of A and B are 2x and 5x. And they have got different radius. Radius of sphere A and B are 3 centimeters and 4 centimeters. Radius of A is 3 centimeters and the radius of B is 4 centimeters. And let the charge on the sphere A be QA and the charge on sphere B QB. The total charge which is to be distributed on the two spheres is 147 microcoulomb. It means that the sum of the charges QA plus QB is equal to 147 microcoulomb. Now we are supposed to find out that what should be QA and what should be QB. We can move forward with it. We know that surface charge density is charge per unit area is sigma. Charge by cross multiplication is sigma into area. Since these are spherical bodies, area of a spherical body is 4 pi r square. Q will become sigma into 4 pi r square. Here, in order to find out the two charges on the sphere, we can call it as sphere A and we can call it as sphere B. Sigma A is equal to, we can call it as 2x, and the radius of A is 3 centimeters. And sigma B is 5x and the radius of B is equal to 4 centimeters. We can put the value for sigma A and sigma B so that we can get the individual charges as such. The charge on A will be equal to sigma A, we can call it as 2x and 4 pi into 3 square. And the charge on B will become 5x into 4 pi into 4 square. We can put the value for sigma and radius in both the cases. Here we will be getting 18 into 4 pi x. Here we will be getting 80 into 4 pi x. Because we need now to put the value for 4 pi and we need now to put the value for x also. Now QA and QB, we are getting 18 into 4 pi x and QB is equal to 80 into 4 pi x. Now we know one more thing, that the sum of the two charges QA plus QB is equal to 147 microcoulomb. QA is equal to 18 into 4 pi x and QB is 80 into 4 pi x is equal to 147 microcoulomb. 98 into 4 pi x is equal to 147 microcoulomb. 4 pi x has got a value of 147 upon 98 microcoulomb, and it will be 3 upon 2 microcoulomb, or we can say it is 1.5 microcoulomb. This is the value for 4 pi x. Now if 4 pi x is 1.5 microcoulomb, then we can find out the individual charges. QA is equal to 18 into 4 pi x. 18 into 1.5 microcoulomb. It will be 27 microcoulomb. The charge which is to be given to sphere A is 27 microcoulomb. Similarly, QB is equal to 80 into 4 pi x, or it will be 80 into 1.5 microcoulomb. It will be 120 microcoulomb. The charge on the sphere B is 120 microcoulomb. Numerical number 5. A charged conducting sphere 1 of radius 2 cm is brought in contact with another uncharged conducting sphere 2 of radius 3 cm. Now the sphere 2 is separately brought in contact with another uncharged conducting sphere 3 of radius 4 cm. If finally the charge on sphere 3 is 60 microcoulomb, then answer the following questions. What was the initial charge on sphere 1? What is the final charge on sphere 1? What is the final charge on sphere 2? Now according to this numerical, the three spheres are 1, 2 and 3 of radius 2 cm and 3 cm and 4 cm. The sphere 2 and 3 are uncharged, whereas some charge is given to sphere 1. Let the charge given to sphere 1 be Q. Now when 1 and 2 are connected to each other, then what will happen? If you talk about sphere 1 and sphere 2, sphere 1 and sphere 2, sphere 1 has a charge of Q and the sphere 2 is uncharged, and the radius of sphere 1 is 2 cm, the radius of sphere 2 is 3 cm. Now when the two are connected to each other, or they are brought in contact, after brought in contact, when they are brought in contact, they'll have equal potential. The electrostatic potential of both will become equal, then the charges will get redistributed. The final charge will be depending upon their radius. More the radius, more will be the charge, less the radius, less will be the charge. The final charge on Q1 is Q1 dash and the final charge on Q2 is Q2 dash will be in the ratio of their radiuses, which is 2:3. The total charge which is to be distributed q, because the charge was on sphere 1 and the charge on the sphere 2 was 0. Initially the charge on sphere 2 was 0. That means whatever charge is to be redistributed, that is only on charge on sphere 1, that is q. So find out the value for q1 dash. q1 dash is the final charge on sphere 1. It is 2:3 is the ratio. 2 upon 2 plus 3 into the total charge q. It will become 2 upon 5 q will be the final charge on sphere 1. The final charge on sphere 2, q2 dash, will become 3 upon 2 plus 3 into the total charge. It will become 3 upon 5 q. These are the final charges on sphere 1 and sphere 2 when sphere 1 is connected to sphere 2. Now we are connecting the sphere 2 with sphere 3. The sphere 2 has got a charge of 3 upon 5 q, and the sphere 3 is uncharged. The sphere 2 has got a radius of 3 centimeters and the sphere 3 has got a radius of 4 centimeters. Now after they are connected, or we can say after they are brought in contact with each other, they'll acquire same potential. The electrostatic potential will become same, and when the two are connected, the charges will get redistributed. The charge will be redistributed in such a way that the final charge will be depending upon its radius. More the radius, more will be the charge. Less the radius, less will be the charge. The final charge on sphere 2 will be q2 double dash is to q3 dash is equal to r2 is to r3. It will be depending upon their radius, it will be depending upon their size, and it is 3 is to 4. The total charge which is to be distributed is the charge on sphere 2 and charge on sphere 3. The two charges will get added up. It will be 3.5 q plus 0. That means the total charge which is to be distributed is 3.5 q. The charge, final charge on q2, it will become equal to 3 upon 3 plus 4 into the charge 3 upon 5 q. It will come out to be 9 upon 35. The final charge on q3, it will be 4 upon 3 plus 4 into 3 upon 5 q. It will be 12 upon 35 q. These are the charges present on the sphere 2 and 3. The final charge on sphere 2 and the final charge on sphere 3. But it is given that the final charge on sphere 3, which is 12 upon 35 q, is equal to 60 microkilo. The final charge on sphere 2 is equal to 12 upon 35 q is equal to 60 microkilo. So what will be q as such? Q will be 60 into 35 upon 12 microkilo. 12 into 5 is 60. Q will become equal to 175 microkilo. That means this is the initial charge on sphere 1. This is the initial charge on sphere 1. And what is the final charge on sphere 1? Final charge on sphere 1 it was 2.5 q, which we have done earlier. It is 2.5 q. It will be 2.5 into 175 microcoulomb. When you solve it, it will be 5 into 3 is 15, 16, 7, 35 into 2 is 70. It will be 70 microcoulomb. 70 microcoulomb is the final charge on sphere 1. Now what will be charge on sphere 2? Final charge on sphere 2. The final charge on sphere 2 which we were getting is 9 upon 35 q. So we can put 9 upon 35. Q is 175 microcoulomb. So 7 into 5 is 35, 5 into 3 is 15, 5 is 25, it will be 7, 5 is 35, 9, 5 is 45 microcoulomb. 45 microcoulomb will be the final charge on sphere 2. Numerical number 6. 3 conducting spheres 1, 2 and 3 of radius 6 cm, 2 cm and 1 cm respectively. The 3 spheres 1, 2 and 3 have positive charges in the ratio of 5:3:2 on them. The spheres 1 and 2 are connected and then separated by insulating hands. Now sphere 2 is brought in contact with sphere 3 and then separated. If the final charge on sphere 2 is 24 microcoulomb, then answer the following questions given below. First question, what is the initial charge on all the 3 spheres? What is the final charge on sphere 1 and 3? Let the 3 spheres be 1, 2 and 3 in this way. They have got radius 6 cm, 2 cm and 1 cm. R1 is equal to 6 cm. R2 is 2 cm. R3 is 1 cm. And they've got charges as Q1, they've got charges as Q2 and they've got charges at Q3. The ratio of Q1 is to Q2 is to Q3. It is equal to 5:3:2. It means that if Q1 is equal to 5Q, Q2 is equal to 3Q and Q3 is equal to 2Q. Now Q can be any constant term. The charge on sphere 1 will be 5Q, the charge on sphere 2 will be 3Q and the charge on sphere 3 will be 2Q. Now when the sphere 1 and 2 are connected to each other, what will happen? Now sphere 1 is connected to sphere 2. The charge on sphere 1 is equal to 5Q and the charge on sphere 2 is 3Q. The sphere 1 has got a radius of 6 cm and the sphere 2 has got a radius of 2 cm. Now when the two spheres are connected, or are brought in contact with each other, then they will have same potential. Then the charges will get redistributed. The charges will get redistributed according to their radiuses. More the radius, more will be the charge acquired by them. Less the radius, less will be the charge acquired by them. The final charge on Q1 will be Q1 dash and the final charge on Q2 will be Q2 dash. It will be depending upon the radius, and which is 6:2. That means 3:1. The total charge which is to be distributed, it will be 5Q plus 3Q. 5Q plus 3Q. it will be 8Q. And the total charge which is to be redistributed. Now the final charge on Q1, it will become equal to 3 upon 3 plus 1 into 8Q. It will become 3 upon 4 into 8Q. It will be 6Q. Similarly, final charge on Q2 dash, it will be 1 upon 3 plus 1 into 8Q. That means 1 upon 4 into 8Q. That will be equal to 2Q. These are the final charges on the sphere 1 and sphere 2 when sphere 1 and sphere 2 are brought in contact with each other. Now, the sphere 2 is brought in contact with sphere 3. The sphere 2 is brought in contact with sphere 3. The charge on sphere 2 is Q2 dash, which is 2Q, and the charge on sphere 3 will become equal to 2Q. This is the initial charge on sphere 3. This was the charge acquired by sphere 2 when it was brought in contact with sphere 1. The radius of the sphere 2 is 2 centimeters and the radius of the sphere 3 is 1 centimeter. When they are connected, or made to touch each other, then they will acquire same potential. Then the charges will get redistributed. The charges will get redistributed according to the radiuses. If the radius is more, that sphere will have more charge. If the radius is less, that sphere will have less charge. That means the final charge on Q2, it will be Q2 double dash, and Q3 dash will become R2 is to R3, which is 2 is to 1. And the total charge, which is to be redistributed, it will become 2Q plus 2Q, 2Q plus 2Q, that will be 4Q. The total charge which is to be redistributed is 4Q. The charge on sphere Q2 double dash will be 2 upon 2 plus 1 into 4Q. That will be equal to 8 upon 3. And the final charge on Q3, it will be 1 upon 2 plus 3, 2 plus 1 into 4Q. It will be 4 upon 3Q. These are the final charges on the sphere 2 and the final charge on sphere 3. Now it is given that the final charge on sphere 2, which is 8 upon 3Q, it is equal to 24 microcoulomb. Final charge on sphere 2 is equal to 8 upon 3Q, and which is equal to 24 microcoulomb. Q by cross multiplication is 24 into 3 upon 8 microcoulomb. Now 8 will cut with 24, it will become 3 into 3, 9 microcoulomb. The Q, we got this. Now what will be the initial charge on sphere 1? Initial charge on sphere 1, Q1 was equal to 5Q. It will be 5 into 9 microcoulomb. It will be 9, 5 is the 45 microcoulomb. The initial charge on Q2 was equal to 3Q. 3 into 9 micro, it will be 27 microcoulomb. The initial charge on Q3 was equal to 2 micro. It is 2 into Q, 2 into 9 microcoulomb, it will be 18 microcoulomb. And the initial charge on the sphere 1 was 45 microcoulomb, initial charge on sphere 2 was 27, and initial charge on sphere 3 was equal to 18 microcoulomb. Numerical number 7. If charge per unit volume is rho 6 microcoulomb per centimeter cube, then answer the following questions. First part, how much charge is present in an imaginary sphere of radius 4 centimeters? Second part, how much charge is present in an imaginary shell of inner radius 5 centimeters and outer radius 6 centimeters? We'll take up both one by one. First one, in this charge distribution, which is 6 microcoulomb per centimeter cube, we have got a sphere of radius 4 centimeters. We want to find out the charge in the sphere. The first part of this numerical says that to find out the charge in a sphere whose radius is 4 centimeters. The second part of this numerical says that in the same charge distribution, what will be the charge present in a spherical shell whose inner and outer radiuses are given to us. Inner radius is 5 centimeters and outer radius is 6 centimeters. And we want to find out the charge present in this ring, in this shell. We will take up with both the parts one by one. First part, now when we are given the charge per unit volume as rho, dq by cross multiplication will be rho into dv. This equation dq is rho into dv will be giving us the value of charge in terms of volume. But we want to have charge in terms of radius. We know that volume of a sphere is 4 upon 3 pi r cube. We can differentiate both sides of this equation with respect to r, with respect to radius. D upon dr of v, d upon dr of 4 upon 3 pi r cube. Four upon 3 pi is a constant term and differentiation of r cube is 3r square. 3 and 3 can be removed. dv upon dr will be 4 pi r square. dv can be written as 4 pi r square into dr. This is the relation between dv and radius, dv and dr. We can put the value for dv in equation 1. We will be getting dq is rho into dv. dv is equal to 4 pi r square into dr. And rho, which is given to us, is 6 micro into 4 pi r square into dr. This is the required equation which we are supposed to integrate in both the parts of this numerical. In order to calculate the charge in the first part of this numerical, Q is equal to integration of 6 micro into 4 pi r square dr from 0 to 4. Here 6 micro and 4 pi are constant terms. They can be taken outside. 6 micro into 4 pi integration of r square dr from 0 to 4. 6 into 4 is 24 pi micro. Integration of r square dr is r cube upon 3 from 0 to 4. 24 pi micro upon 3 r cube, that is 4 cube minus 0 cube. It will cancel, it will be 8 pi micro into 64 minus 0. 64 into 8 is 512 pi microcoulombs. This is a total amount of charge which is present in a sphere of radius 4 centimeters. Now, in the second part of this numerical, we have to find out the charge in a spherical shell whose inner and the outer radiuses are 5 and 6 centimeters respectively. We can find out the charge Q, integration of 6 micro into 4 pi r square dr from 5 to 6, because the inner and the outer radii are 5 and 6. Here 6 micro and 4 pi are constant terms. 6 micro into 4 pi can be taken outside. Integration of r square dr from 5 to 6. 6 into 4 is 24 pi micro. Integration of r square dr is r cube upon 3 from 5 to 6. It will be 24 pi micro upon 3. It is 6 cube minus 5 cube. This 3 will cancel with 24, it will be 8. 8 pi micro into 6 cube is 216 minus 125. Now here it is 8 pi micro. Now 216 minus 125 is equal to 91, and 91 into 8 is 728 pi micro. Coulomb is a charge present in the spherical shell whose inner and the outer radii are 5 centimeters and 6 centimeters respectively. Numerical number 8. What is the amount of positive charge present in 3.5 kg of nitrogen gas whose molecular mass is 28? Take Avogadro's number as 6 into 10 to the power of 23. Before we could move forward with this numerical, we should know about nitrogen atom. Nitrogen atom has got 7 protons and 7 electrons. We are only bothered about the positive charge. That means we are bothered about only 7 protons. We will not take up electrons. Now there are 7 protons. But if it is nitrogen molecule, nitrogen is a diatomic gas. It has got 2 atoms which combine together to form one molecule. In nitrogen gas, of one molecule of nitrogen gas has got 7 plus 7, that is 14 protons. Now we have to count the number of molecules to count the number of protons, and one proton has got a charge of 1.6 into 10 to the power of minus 19 coulombs. Before we could move forward with the charge, we should count the number of protons. We should count the number of molecules which are present. The molecular mass of the nitrogen gas or nitrogen molecule is 28. It means that 28 grams of nitrogen gas has 1 Avogadro number of molecules. 1 Avogadro means 6 into 10 to the power of 23 molecules. If 28 grams of nitrogen gas has 6 into 10 to the power of 23 molecules, we can use unitary method to find out the number of molecules in 3.5 kg also. So 1 gram of nitrogen gas gas will have 6 into 10 to the power of 23 upon 28 molecules. And 3.5 kg. 3.5 kg means 3500 grams, 3500 grams of nitrogen gas will have 6 into 10 to the power of 23 upon 28 into 3500 molecules. That means 3500 grams or 3.5 kg of nitrogen gas will have so many molecules. So one thing is clear, we have calculated number of molecules in 3.5 kg of nitrogen gas. Number of molecules is 6 into 10 to the power of 23 upon 28 into 3500. These are the number of molecules. Now one molecule has got 14 protons. So we can count the number of protons. Number of protons present in 3.5 kg of nitrogen gas. It will be number of molecules, which is 6 into 10 to the power of 23 upon 28 into 3500. These are the number of molecules into 14. That will be giving us the number of protons. Now we can calculate the charge, total charge which 3.5 kg of nitrogen gas will have. Total positive charge in 3.5 kg of nitrogen gas. It will be 6 into 10 to the power of 23 upon 28 into 3500. These are the number of molecules into 14 will be the number of protons into 1.6 into 10 to the power of minus 19. That will be coulombs. This is the total charge present in 3.5 kg of nitrogen gas. If you solve it, it will be 6 into 3500 into 14 into 16 upon 28 into, we can say, 10 into 10 to the power of 23 minus 19. If we will solve it, 0 0 will cancel, 7 4s are 28, 7 5s are 35, 14 4 4s are 16. Now we will be getting 6 5 30, it will be 30 0 300 into 14 into 4 into 10 to the power of 4 is the coulombs. 300 into 14 into 4, we can pick it up here. The total charge will be 300 into 14 into 4 into 10 to the power of 4 coulombs. Now 4 3 is 1200 into 14 into 10 to the power of 4 coulombs. So it will be 12 into 14, 168. It will be 16800 into 10 to the power of 4 coulombs, or we can say 168 into 10 to the power of 6 coulombs. So 168 10 to the power of 6 means mega coulombs. The total charge which is present in 3.5 kg of nitrogen gas is 168 megacoulombs.